In the first video of this series, we looked at what is a game object and what are components. And now that we have that down, we're ready to jump right into creating our own scripts. And we do that because we need to create our own logic, our own set of rules for what our game is going to do. And we do that by writing our own scripts. Now we're going to be using C# to write our own scripts. And let's jump right into creating a script. And what we're going to cover in this video are what are variables and what are functions. So first of all that we've done so far is I did do a save on my scene, and that created the scene file, but that's the only asset in the project. Now I like to click this and shrink it down so that I can see my files at this smaller size. But I see that there's no scripts. Actually, there's nothing in this project at all except one scene file. So we're going to create a script now, and you can create a script multiple ways. I could click in a folder down here anywhere and say create a C# script. That would work, and it would put it into that whichever folder we put it into. The other way to create a script is to select a game object and say add component. And if you don't have anything in your search box, you could select from anything in here, including some scripts, but there's all of your physics, rigid body, and all that. But if you type something here that doesn't exist, like my script, you could say new script here, and then you could say create and add. So that will do the same thing that this does, to where it creates a new C# script. So let's go ahead and create a new C# script. I want to put the script, we'll just put it into the assets folder. So I'm going to say create a C# script, and I'm going to call this my first script. Now you'll notice that I capitalized the word my, the word first, and the word script. And that wasn't just a random choice of mine. That's actually a proper capitalization style. And so I'm on the Microsoft Developer Network. And because we're developing in C#, let's look at, this is called Pascal case. The first letter in the identifier and the first letter of each subsequent word is capitalized. So you can see the first word's capitalized and all next words are capitalized. That's called Pascal case. And the next one is camel case, where the first letter is lowercase and then all the next words are capitalized. So you see the first word is lowercase and the rest are capitalized. And so here it tells you when you should use Pascal or camel case. And when I create a new script, I'm actually creating a class. And so you could see that the class should use Pascal case. So that means that when I create a script, the first letter should be capitalized, and all the other words after that should be capitalized as well. So that's why I named it my first script, and I'm going to double click on this to open it up with Visual Studio. Now I prefer Visual Studio myself, but Mono Develop would work as well. It's basically the same experience. Now you'll see that a public class has been created. It's called my first script. And so that's like I said, when you create a new script, it actually creates a class for that, and that is why the script and the class should be in Pascal case. And Unity creates two functions for us. One is called start and one is called update. And we're going to get into the mono behavior functions in a future video, but for now we're going to first define what are variables and what are functions. So a variable is something that saves data, and functions is code that does something. So there's a lot of different data types. And again, I'm back on the Microsoft Developer Network looking at the data types of C#, and we could see that there's bytes, integers, shorts, longs, floats, doubles, characters, booleans, objects, string, and decimal. And then when you get into Unity, Unity has all kinds of data types. But for today, we're just going to be looking at the C# data types. And basically, bytes, integers, shorts, longs, floats, doubles, those are all numbers. And it explains what type of number that is here. And the most commonly used is the integer and the float in Unity development anyways. And so the next ones that we use a lot is the Boolean, which is a true or a false value. And then there is string, which is just any sequence of characters. So this, for example, is a string. We'll look at that in a second. I'm going to go back into Unity and I'm going to bring up my script. And we already know what the data types are. Let's look at how to define those. First of all, to make a variable, we have to say what type it is. So I'm going to say int. I'm going to start with int. So it's spelled just like this, int. And that tells C# that we're making a new integer. And then we have to give it a name. So I could call this number of donuts. And remember, it's important that I put a lowercase in here. And the reason why, of course, is the capitalization style. Whenever we are doing, we'll have to go down to parameter. You'll see that it's supposed to be camel case, and that means that it starts with a lowercase, and all the words after that are uppercase. So when I make a variable, the first word is lowercase, and all the words after that are going to be uppercased. Now, if I put a semicolon at the end, that's okay, and we have actually defined a variable now, and we could use this variable later in our code. Now, I haven't given a value to this, so it's actually going to be 0, but we could assign a value. Before we do that, let's go ahead and see what the value of this is. And we can find that out by using a command called debug.log. And debug.log lets us put a message in here, and it will log it to the console. So I'm going to say debug.log number of donuts. So it's just going to print whatever this value is to the console. So I'm going to go into Unity, and this happens on start, which happens when you start the game. So if I press play, we should get a value logged. Now, nothing has happened, and the reason why is because all I did was right-click down here, and I said create a script. But none of these game objects have that script assigned to it. So I'm going to select one of the game objects, and we can assign it to any one of them. But for this, I'm going to go ahead and pretend that we're going to do something with this cube. So I'm going to add a component to the cube, and I'm going to say my first, and it already popped up. It says it found my first script. Now Unity has split the words apart here for us because I use the proper capitalization style, and it says my first script. We've added that to the cube game object, and now we're ready to start the game. I'm going to click onto my console, and if I wanted to get that window back, I could click into here and say console, and then I'm going to press play, and it starts, and it logs a value of 0. Okay, so we see that this is 0. There's no donuts. So the next thing that you could do when you define a variable is automatically give a value to it. So you say equals sign, and then you can give it a value. So I'm going to say equals 5. So now the number of donuts is equal to 5. And if we start the game, let's see what happens. We should get a log that says 5 because the number of donuts is 5. So that's what a variable is. And there's another word that we could use that goes before we define the variable, and that defines the scope. So here I am on the variable and method scope for .NET, and here are the scoping terms and what they're used with. So what we're working with right now are properties, and so we can say public property, a private property, a protected property, a friend property, a protected friend, and we could see the visibility here. Public lets it be seen by anything in the project, by any other script, and that's very useful in Unity. I'm going to show why in just a second. Private is only in the block where it's defined, so that means that another script could not see this variable. Only this one script has access to it. And that's all that we're going to get into right now, the public and the private. And so we define that right here before. So I could say private int number of donuts equals 5. And I'm going to copy this line and paste it above, because normally the public variables are listed first. And I'm going to change this one to public. Now this is going to give us an error because you can't have two variables that have the same name. It doesn't know how to differentiate between them two, so we're going to have to call this one something else. We'll call it number of bagels. And we have 2 bagels. So I've made one of these public and one of them private. And again, private means that only this script has access to it, and public means that any script in the project, it will be able to get access to this variable. But there's another really handy thing that happens when you make a variable public in Unity. When you make a variable public in Unity, it automatically gets populated as a variable here in the Unity inspector on the component itself. And you can change that right here without going into the script. So if I wanted to change the number of bagels to 12, I could do that. And right now, nothing is happening with the number of bagels. So let me change the debug.log. And I'm going to put a quote here. So I say donuts. I'm going to put a space. I'm going to use the plus symbol to concatenate this with this. And then I'm going to copy this line. I'm going to do the same thing except with bagels. And of course we're going to list the number of bagels. And so what we'll see now is Unity will tell us the number of each one. And we get this little text so we know which is which. So the donuts is 5, but the bagels is 12. And if I want to modify the number of bagels to 16, that's going to work right off the bat. And that's one of the nice features of making a variable public inside of Unity. So now that we know what a variable is, let's look at what a function or a method is. Because the variables are saving data and the functions are going to do things with that data. So I'm going to make a new function, and we can already see how the functions are worded. First, we define what type of data the function is going to return. And in this case, let's just use void. And that means that no data will be returned. And we'll discuss that a little bit more in just a second. But we're going to say void add food together. And we could see that we put these two parentheses. And after that, we put 2 brackets. And this is how you define a function. And usually we would go like this, and then the code for the function goes here. And of course you could also line up your brackets like this. It's up to you how you prefer. So this, we're going to do something, and instead of doing this debug.log here, I'm going to put 2 slashes, which comments that out so the code isn't run. And what I'm going to do is I'm going to make a new integer, and I'm going to call it total food. And that's going to be equal to the number of bagels plus the number of donuts. And once I know the total number of food, I'm going to say debug.log total food. And then we should know how much total food we have, which is going to be 16 bagels and 5 donuts. So we should have 21 food. And if I press play, nothing has happened. And the reason why is we've created a function, but it's never called in any code. A function by itself is never automatically called. This code is not automatically executed ever unless that function gets called. Now, start and update do run automatically. Start runs once when you start the game, and update it runs once per frame. So just like a TV runs at 30 frames a second and a computer screen runs at 60, your game runs at in a loop a certain number of times per second. Let's say 60 times per second. So that means that this update function would be called 60 times per second. We don't want to do this 60 times per second. So just in start, I'm going to call the function called add food together. To call a function, you just type the name and you put the parentheses with a semicolon. So now when it starts, it's going to run the function called add food together. And now this code will run. Let's hit play and see what happens. We get 21 logged. That means that the function definitely ran and it logged the total food, which is the number of bagels plus the number of donuts. So we can see what variables are. They save data values, and we can see what functions are. They perform actions. But a function doesn't have to return void. It can actually return a data type. So let's say I typed integer here, and I'm going to say add numbers. Now, what I'm going to do in this parentheses is I'm going to allow 2 variables to be sent into this function when it's called. And first I have to tell it what type of variables, and the only type of variables we're using so far is integers. So I'm going to say integer number A, and then integer number B. And of course we need our 2 brackets. And we've defined a variable, or we defined a method that is going to return an integer, and it's called add number. So basically we're going to want this function to add the numbers together and then send it back. So what I'm going to say is I'm going to make a new integer, and I'm going to say total, and total is going to be equal to number A plus number B. And there is a red line under this, and if we look at it, it says it doesn't return a value. So we have to type the word return, and it knows we need to return an integer because that's what type of function we told it returns. And so I'm going to say return total, and that's going to send the total back. So if I call this function and I pass one integer in and another integer, this function is going to add those 2 together and then send me back a new value. So now I'm going to take out this function. We don't need that one anymore. And what I'm going to do when we start is I'm going to say add number. And you can see here that number needs 2 integers inside the parentheses. Well, I have 2 integers here, so I'm just going to say number of bagels with a comma, and then I'm going to say number of donuts and put a semicolon at the end. Now this actually is going to add those 2 together, but nothing happens with it. So I need to make a new integer to save that value in. So I'm going to say integer, and I'll call this one total food again, I guess. and that is equal to add number of bagels, and the number of donuts. So remember, this function returns an integer value, so this gets sent, basically this replaces all of this. So typing this is the same as typing total food is equal to 21. We're going to get the same result either way. So now that we have our total amount of food, I'm going to say debug.log, and I want to log the total food. And now let's see what happens. Just to make sure that I didn't accidentally call this function, I'm going to go ahead and delete the add food together, because we're adding the food together a different way with this function called add number. And the nice thing is, add number could be used over and over again to add together all kinds of different things, like my number of bananas, spell it right, but the number of bananas and the number of walnuts, we could call this, and it's just going to add whatever the two numbers that we pass in. So this function is better than the first one I wrote, because this one is reusable, and the one that I had deleted down here, if I Control Z back to it, here it is. This one is not reusable because it only adds together these direct values. So anyways, we're deleting that one because we have a better way to add the food together. And now we're going to debug.log total food. We should get the same number again. I'm clicking clear to clear that out. And so if I hit play, we're going to get 21 again. And now we have seen how to use variables, how to use functions, and how to define our scope. Now I want to point something out. I had used the integer name total food, the same exact variable name, twice. It's used here and it's used here. And we got to remember, we can't use the same variable name. But in this case, it's okay, because this is when I define the variable inside of a function in this manner by just saying integer and then giving it a name. It's only accessible and used within these brackets. And outside of that, it doesn't exist. So that's why down here, I create another total food. That's okay, because this one, again, is only accessible within these brackets, because I haven't defined it up here. So if I were to make a private variable up here called total food, then now we can't name these ones total food, because there's already one that has using that name. So that is variables and functions. And in the next video, we're going to cover the different types of data classes that we actually use frequently in Unity, and write a couple more functions. So if this helps you out, make sure to hit the like button and subscribe. I'll see you guys in part 3.